How does an engine work? Inside, almost every car is a machine that turns fuel into motion. Let's open one up and see exactly how it works. An engine has one main job: to turn fuel into movement. It does this using a simple but powerful idea: controlled burning. When you mix fuel with air and light it with a spark, it burns and expands, pushing outward hard and fast. An engine captures that push and turns it into spinning motion for the wheels. One burn gives one small push, but an engine repeats this hundreds of times every second. All those tiny pushes add up, enough to move a heavy car, climb a hill, or cruise down the highway. You might wonder why the engine needs air, not just fuel. The answer is that fire needs oxygen to burn, and air is about 1/5 oxygen. Without air, fuel can't burn at all. That's why the engine breathes. Every cycle, it pulls in a fresh gulp of air and mixes it with a fine mist of fuel. Get the mix right, and it burns with a powerful, clean push. This is also why the engine has to breathe out, to clear the old air and make room for fresh oxygen each time. Before we see it run, let's meet the main parts. This is a single cylinder, a smooth round tube inside the engine. Inside the cylinder is the piston, a solid metal plug that slides up and down. Below the piston is the connecting rod, a strong metal arm. The top of the rod is attached to the piston, and the bottom connects to the crankshaft. The crankshaft is a spinning shaft with an off-center section, and this spinning is what eventually drives the wheels. At the top of the cylinder are two valves, doors that open and close. The intake valve lets fresh fuel and air in. The exhaust valve lets the burned gases out. And right in the middle sits the spark plug, which makes a tiny spark to light the fuel at just the right moment. These parts work together to turn burning fuel into motion. Here's one of the cleverest ideas in the whole engine. The piston can only move in a straight line, up and down, but the wheels need to spin in circles. So how do we turn straight line motion into spinning motion? That's the job of the connecting rod and the crankshaft. The crankshaft has a section that's offset from the center, like the pedal on a bicycle. As the piston pushes down, the connecting rod pushes on that offset part, forcing the crankshaft to rotate. As it keeps spinning, it pulls the piston back up, ready for the next push. Up and down becomes round and round, the same motion you make when you pedal a bike. A car engine does its work in 4 steps, called strokes. A stroke is just one trip of the piston, either up or down. The 4 strokes always happen in the same order: intake, compression, power, and exhaust. Together, they make one complete cycle. Let's walk through them one at a time, slowly, then we'll watch them run at full speed. Stroke 1, intake. This is the engine taking a breath in. The piston slides down inside the cylinder. At the same time, the intake valve opens. As the piston moves down, it makes more room above it, creating a partial vacuum, low pressure that pulls air and fuel into the cylinder, just like pulling back on a syringe draws in liquid. The mixture of fuel and air rushes in through the open intake valve to fill the space. The exhaust valve stays shut, so everything is drawn in through that one open door. By the time the piston reaches the bottom, the cylinder is full of a fresh mixture, ready to be used. Then the intake valve closes, sealing it shut. Stroke 2, compression. Now both valves are closed, sealing the cylinder tight. The crankshaft pushes the piston back up. As it rises, it squeezes the fuel and air into a much smaller space, packing it into about 1/8 of its original size. Why squeeze it? Because compressing the mixture makes it far more powerful when it burns. Think of squeezing a spring. The tighter you compress it, the more it pushes back. The piston keeps rising. The pressure climbs higher and higher, and the mixture gets hot and tense. Just before the piston reaches the very top, everything is squeezed and ready. The stage is set for the big moment. Stroke 3, power. This is the moment the whole engine is built for. With the fuel and air squeezed tightly at the top, the spark plug fires, a tiny spark of electricity. The mixture ignites and burns almost instantly, expanding with tremendous force. That expanding gas slams the piston downward, hard. This is the only stroke that actually produces power. The force travels down through the connecting rod and gives the crankshaft a strong turn. Both valves stay closed, so all of that energy goes straight into pushing the piston. This is where fuel becomes motion. People sometimes call this the bang, the controlled explosion that brings the engine to life. Stroke 4. Exhaust. After the fuel burns, it leaves behind hot waste gases that need to get out, so fresh fuel can come in. Now the exhaust valve opens, the crankshaft pushes the piston back up again, and this time it acts like a pump, pushing the burned gases up and out through the open exhaust valve. These gases travel out through the exhaust pipe and leave through the tailpipe at the back of the car. By the time the piston reaches the top, the cylinder is empty and clean, ready for fresh fuel and air. Then the cycle begins again. Intake, compression, power, exhaust, and back to the start. Let's put all 4 strokes together and watch them flow. Intake. The piston drops and breathes in. Compression. It rises and squeezes. Power. The spark fires and pushes it down. Exhaust. It rises again and pushes the waste out. Then it repeats over and over. Here's something surprising. It takes 2 full spins of the crankshaft to complete just one of these cycles, and the engine does this incredibly fast. At highway speed, each cylinder can fire around 50 times every second. That's why an engine hums, thousands of tiny controlled burns blending into a smooth, steady stream of power. You might be wondering, how do the valves know exactly when to open and close? That's the job of the camshaft. The camshaft is a rod that spins along with the engine, and it has egg-shaped bumps called lobes. As a lobe rotates around, it presses down on a valve and pushes it open. As the lobe turns away, a spring pushes the valve closed again. Because the camshaft is linked to the crankshaft, the valves always open at the perfect moment, in perfect time with the piston. If the valves opened at the wrong moment, the engine simply wouldn't run. Everything inside is choreographed, like a dance, down to a fraction of a second. Here's a puzzle. If only 1 stroke out of 4 actually pushes, what keeps the engine turning during the other 3? The answer is the flywheel, a heavy metal wheel attached to the crankshaft. When the power stroke gives its push, the flywheel stores that energy as spinning momentum, just like a merry-go-round that keeps turning after you stop pushing it. That stored momentum carries the piston smoothly back up through intake, compression, and exhaust until the next push arrives. The heavier the flywheel, the smoother the engine spins between bursts. So far, we've watched just 1 cylinder, but most cars don't have one. They have 4, 6, or even 8. Why? A single cylinder only makes power during one of its 4 strokes. The other 3 actually take energy, not give it, so 1 cylinder alone would feel jerky. 1 push, then a long pause, then another push. The solution is to use several cylinders and stagger their timing, so they take turns. While 1 cylinder is on its power stroke, another is compressing, another is breathing in, and another is pushing exhaust out. Their pushes overlap and blend together. The result is smooth, steady, continuous power. More cylinders generally means a smoother engine, and often more power. Most engines run on one of 2 fuels, gasoline or diesel, and they light their fuel in slightly different ways. A gasoline engine works exactly as we've seen. It mixes fuel and air, then uses a spark plug to light it. A diesel engine skips the spark entirely. Instead, it squeezes the air so hard that it becomes scorching hot, hot enough that when diesel fuel is sprayed in, it bursts into flame all on its own. Same 4 strokes, same basic idea, just a different way to start the fire. Both turn fuel into motion. So we've made the crankshaft spin. How does that actually move the car? The spinning crankshaft sends its power into the transmission, a set of gears that adjusts the balance between speed and strength, depending on whether you're starting from a stop or cruising fast. From the transmission, the power travels through a shaft and into the wheels, turning them so the car rolls forward. So here's the full journey. Fuel and air burn inside the cylinder. The explosion pushes the piston down, the piston spins the crankshaft feeds the transmission, and the transmission turns the wheels. A few drops of fuel and a car rolls down the road. One last thing. All this burning and rubbing makes an engine very hot, and its metal parts slide against each other thousands of times a second. To survive, an engine needs two helpers. Oil coats every moving part so they glide instead of grinding and wearing out, and coolant, a special liquid, flows through the engine to carry heat away, stopping it from overheating. Fuel makes the power, but oil and coolant are what keep an engine running for years without destroying itself. Let's recap the 4 strokes one more time. Many people remember them with 4 simple words: suck, squeeze, bang, blow. Suck, intake. The piston drops and pulls in fuel and air. Squeeze, compression. The piston rises and packs that mixture tight. Bang, power. The spark fires and the explosion drives the piston down. Blow, exhaust. The piston rises again and clears out the burned gases. 4 strokes, repeated thousands of times a minute, in cylinder after cylinder. That's how burning fuel becomes the smooth, powerful motion that carries you down the road. Thanks for watching. The next time you start a car, you'll know that underneath you, thousands of tiny explosions are firing in perfect order. Suck, squeeze, bang, blow.